Welcome to Grateful, where we provide SAT, ACT, and PSAT instruction to students anywhere in the world. Our novel approach to the SAT comes from thousands of hours of instruction with actual students and is based in the idea that the SAT is a content-based test full of references and code words to things that you're supposed to know. And we strongly believe that if you know those things, you'll be that much closer to getting your best possible score on the SAT. Right now, we're working on College Board's SAT Practice Test Number 2, Non-Calculator Math section. The best way to take advantage of this video is to find College Board's SAT Practice Test 2 on the College Board or Khan Academy websites, try the test on your own, and then refer to these videos for the most effective ways to answer the questions. Another thing you can do is watch the video, pause when you see each new problem, and then press play to watch the solution to each of the questions. Let's go ahead and jump right in. Question number 1. This is what we refer to as a corralling question. In a corralling question, it's better not to try to find x and plug it into the new expression. Instead, what you should do is think of simple chess moves that get you from the given expression to the target expression. Let's go ahead and show you what that means here. Here, we know that 5x plus 6 equals 10. What we want to know is the difference between what we have, 5x plus 6, and what we need, 10x plus 3. The more common thing that happens on a lot of these questions is that you can just multiply or divide by a single number to get from 5x to 10x, and you'd be done on a question like this. That doesn't particularly work here, because to get from 5x to 10x, we have to multiply by 2, but to get from 6 to 3, we're actually dividing by 2. So it won't be as simple as some of the corralling questions that we see. Instead, we can focus on the relationship between 5x and 10x and just go ahead and focus on that. So let's go ahead and just subtract 6 from both sides. That'll give us 5x equals 4. And now to get the 5x into the 10x, we can just multiply by 2. And now we have 10x equals 8. So what's 10x plus 3 equal to? We can just go ahead and add 3 to both sides. That'll give us 10x plus 3 equals 8 plus 3, which is 11. And the answer for number 1 is going to be C. Question number 2 is a system of linear equations. We know these are linear equations because x and y are both to the first power on both equations. When you have a system of linear equations, you want to use either substitution or elimination to solve. Substitution is better if it's easier to get x or y all alone. Elimination is better if the x's, y's, equal signs, and numbers all line up. On this easier question, because it's at the beginning of section 3, I would say substitution or elimination would both be really easy to do. But in my personal opinion, elimination is even easier than substitution. So let's go ahead and try elimination. We can multiply both equations by things that are either going to make x or y drop out. To me, it just looks super easy to take the top equation and multiply it by 2, and that's going to make the y's drop out. So let's just go ahead and rewrite the bottom equation, and after we've multiplied the top equation by 2, we're going to have 2x plus 2y equals 0. There, the left-hand side multiplied by 2, and so did the right-hand side, but because 0 times 2 is 0, it kind of looks like nothing happened there. But the whole purpose of what we just did is to create a situation where the two y's are lining up and are opposite of one another. That's going to allow us to add straight down. When we add straight down, we'll have 3x plus 2x, which is 5x, negative 2y plus 2y, which cancels away, and 10 plus 0, which is 10. That gives us a nice simple 5x equals 10. We can divide both sides by 5. We can divide both sides by 5. And that gives us x on the left and 2 on the right. So now that we know that x is 2, only one of the answer choices has x equaling positive 2, so we already know that the answer to this is B. Question number 3 is asking us about a really important concept on the SAT, which is the idea of price times quantity statements. So for instance, if you go to the mall and you buy 5 sweaters and each sweater costs $20, then 5 times 20 is 100, so you're going to be spending about $100 on sweaters. So 20 is the price, and 5 is the number, the quantity, so the price times quantity. And that idea gets tested a lot throughout the SAT. This kind of seems like a price times quantity statement on steroids because there are actually three things we'll be multiplying together. Before we get into that, we should note that whenever you're doing a challenging word problem or something with a lot of moving parts, something a little more on the complicated side, you want to really be sure of what each variable stands for. That's going to help you think a lot more clearly. So, on my own, taking an SAT, I probably would write out N is the number of landscapers working the job, H is the number of hours that the job will take, and 12 stands for, well, we don't really know what 12 stands for because that's what the question is asking us. One thing to observe here is that the equation that's being given to us is a linear equation. It's linear in the sense that it has a starting constant and then a variable movement. So if we were looking at this graph, it looks like it would start at 60 and then it would increase up linearly by some kind of slope that has something to do with either 12, N, or H, or some combination of that we can't quite understand just yet. Now thinking this through, kind of like when we were talking about having 5 sweaters and each one costs $20, if we have N landscapers and each landscaper works 8 hours, then so far, to find the amount of money that's going to have to be paid, we'd have to multiply the N times the H to get the total number of hours. So if each landscaper spends a certain number of hours and there are N landscapers, it's kind of like a price times quantity statement to take the N and multiply it by the H. I still wouldn't exactly call that expression a price times quantity statement. I would say that the N times the H is itself the quantity. And the reason I would say that is that we're still going to take that and multiply it by 12. So it kind of makes sense in this strange situation that the price is 12. Let's think this through again. We have N landscapers, each one is working H hours, so the total number of hours is going to be H multiplied by the N landscapers. So it's a complicated one, but it's a quantity nonetheless. It's the total number of hours, N times H. So, as we mentioned, when we have quantity, price is usually somewhere around, and so the price will be 12. And price times quantity is 12 NH. So what does that make the 12? It makes 12 the hourly rate for each worker, because we have a certain number of hours, which is this whole thing right here, the total number of hours the company is going to pay, and we're multiplying that by 12, the amount of money we're going to pay per hour. All of this matches A, so the answer for 3 is going to be A. And before we wrap up, we want to just talk about the idea that when you have price times quantity statements, the thing we call the price is not always money. For instance, we could have a situation where each dog weighs 5 pounds and each kitten weighs 4 pounds, and we have X kittens and Y dogs. So 4X plus 5Y in this situation that I just made up is the price times quantity statements for the kittens and the dogs. So the idea is that the price is the number that goes along with each item. To be honest, on most problems it will actually be money, but it's the same idea even if we're talking about something that's not specifically money. So let's go ahead and go to number 4 now. Number 4 is a question on perfect square trinomials. Factoring trinomials as a perfect square is definitely one of the things you want in your arsenal when you're going into an SAT. Now, how did I know that it was about perfect square trinomials? Because I've already got the shape of the classic perfect square trinomial in my head. The classic perfect square trinomial looks something like this: x squared plus 2xy plus y squared. And that's the expanded form of x plus y all squared. Let's just quickly prove that out by saying that x plus y squared, well, squaring is the same as x plus y times x plus y. And if we were multiplying this back out, we would do first times first, outer times outer, inner times inner, last times last, which is FOIL. First times first is this times this, and that gives you x squared. Outer times outer is this times this, and that gives you xy. Inner times inner is this times this, and that gives you yx, but we're going to also say xy, because the convention in that situation is to put them in alphabetical order. So once again, we have xy, and last times last is y times y, which is y squared. So finishing out the FOIL, all we have to do is combine our like terms. Xy plus xy is 2xy, and we have x squared plus 2xy plus y squared. So by foiling, we demonstrated that x plus y all squared, which is x plus y times x plus y, is actually equal to x squared plus 2xy plus y squared. And the same holds backwards. If I showed you x squared plus 2xy plus y squared, you should be able to say, well, that's x plus y squared. And the way to get there is through something that we call the perfect square test. Now, once again, we identify a perfect square trinomial because it's got a certain format that we recognize from doing a lot of practice on this. But once we have a hunch that it might be a perfect square trinomial, we run the perfect square test. For the perfect square test, you need to know that the first term is a perfect square. You also need to know that the third term is a perfect square. And you finally need to know that the middle term is going to be equal to 2 times the square root of the first times the square root of the third. And that'll make more sense in a second. So this is what you'll need to memorize in order to be able to do the perfect square test on your own. And I'm just going to demonstrate it with the x squared plus 2xy plus y squared. In this situation, is the first term a perfect square? Yes, because the square root of x squared is x. And you want to go ahead and write that out when you're doing this. Is the third term a perfect square? Well, yes, because the square root of y squared is y. And is the middle term equal to 2 times the square root of the first times the square root of the third? Here's where it helped that we were writing out the square root of the first and the square root of the third as we were going along, because now we can just go ahead and say that the middle term must be equal to 2 times x times y. And it actually is. It's equal to 2xy. So the x squared plus 2xy plus y squared, it passed all 3 steps of the perfect square test, and there was one more benefit of writing it out step by step the way we did. Once a trinomial has passed the perfect square test, you can take those first 2 square roots that you found, and that's actually what it factors to. X and y all squared, and last but not least, if you had a plus sign in this spot right here before the second term, then you put a plus sign in between the x and y. But if you had a minus sign in that same spot, then it would have factored to x minus y squared. So this is a little weird, admittedly, but it helps a bunch if you've got these steps memorized before you try a problem like this. Now let's go ahead and apply it to question number 4 specifically. As we're doing that, let's notice that there's some kind of similarity between this trinomial right here and this trinomial right here. They've both got numbers that look like perfect squares in the first and third positions, and something that's a little bigger in the middle. Because of the 2 times x times y, it's probably going to give you something a little on the bigger side. But let's go ahead and run the test specifically. Is the first term a perfect square? Well, what's the square root of 9a to the 4th? That's 3a squared. Is the third term a perfect square? Well, what's the square root of 4b to the 4th? And that answer is 2b squared. Now for the tougher one, is the middle term equal to 2 times the square root of the first times the square root of the third? Well, let's see if it is. We've got 2 times the 2 things that we wrote already, 3a squared and 2b squared. Multiplying that out, 2 times 3 times 2 is 12, and the a squared and b squared come along, and what do you know? We have exactly this. So to recap this, we ran the perfect square test. The first term turned out to be a perfect square, and we wrote its square root down. The third term turned out to be a perfect square, and we wrote its square root down. And the middle term turned out to be equal to 2 times each of those numbers that we wrote down. So we passed the perfect square test. Like we did in our last example, that means that this will factor to each of those terms with a square on the outside. And the last piece is simply that if the middle term has a positive sign right here, then we end up with a positive sign in the middle. And if that middle term had a negative sign there, then it would have been 3a squared minus 2b squared, all squared. So the answer to 4 is A. Question number 5 is a radical equation, and the big thing to remind yourself about when it comes to radical equations is that when you get your answers, you have to plug them back in at the end to check them. I'm not quite sure if that'll be a factor here, but it's so important and it leads to so many wrong answers that I can't pass through a situation like this without reminding you of that. But the nice easy way to start this question is to deal with the fact that we're being told x equals 7, so let's just go ahead and plug in x equals 7. So there we have the exact equation we were given, just replacing x with 7. Now the main way to solve radical equations is by isolating the radical, and that allows you to square both sides. So the way to isolate the radical is to add 7 to both sides, and that'll give us the radical on the left, and it'll give us 7 on the right. Now that we've isolated the radical, it puts us in a position where we can square both sides to get rid of the radical. So we'll square both sides. On the left-hand side, that'll get rid of the radical. On the right-hand side, 7 squared is 49. Now we have only one variable, so we can just solve for that variable by isolating it. So let's take away 17 from both sides. And that'll give us 2k squared on the left and 32 on the right. And now to get k squared by itself, we can divide by 2 on both sides. And that'll give us k squared equals 16. Finally, we can take the square root of both sides, and that'll give us k equals plus or minus 4. It's important to remember when you take a square root of a number, there's always a plus and minus outcome, and a lot of times it won't be a factor, but it's almost like the one time you don't think about it is the time you'll need it. Now, like we said in the beginning, with radical equations, you want to plug your answers back in to check them. In this particular situation, that won't be necessary because -4 is not an answer and +4 is an answer, so it's our only answer, and so we kind of have to take it. So the answer to number 5 is going to be C. Question 6. The biggest thing that jumps out at us in question 6 is that the lines are parallel. The most basic thing that parallel means is that they have the same slope. So it's easy to find the slope of line L. Let's just go ahead and get the slope formula. And a really easy way to do slope, so that you don't make a mistake, is label the 2 points x1, y1 and x2, y2. Plugging in accordingly, that'll give us 2 minus 0 over 0 minus -5. We should be a little careful with the double negative on the bottom, so -5 is the same as +5, so we'll have 2 on the top and +5 on the bottom, and so the slope is 2/5. Now let's go ahead and find an expression for the slope of the second line. Even though we have that variable there, we can still arrange it according to the slope formula. So, to avoid a mistake, we'll label the points x1, y1 and x2, y2. And now we can grab the slope formula again, and we can plug into it accordingly. So y2 minus y1 is 0 minus -4, and x2 minus x1 is p minus 0. So here we can be careful with the double negatives again. Minus -4 is +4, and p minus 0 is just p. So the definition of parallel lines is that they have the same slope. So we have 2 over 5 as the slope of one line, and 4 over p as the slope of the other line. So let's go ahead and set those equal to one another. 2 over 5 equals 4 over p. And a boring but super important rule for the SAT is whenever you have a proportion, you want to cross multiply. A proportion is 2 fractions set equal to one another, and so here we can cross multiply. 2p equals 4 times 5, which is 20. Divide both sides by 2, and we get p equals 10. So the answer for number 6 is going to be D. Question 7 combines exponent shortcuts and the difference of squares concept for factoring in a really unique way. So the first thing we can do here is use the exponent shortcuts. The shortcut I'm talking about is the idea that if you had a to the b over a to the c, that would be equal to a to the b minus c. Similarly, if you had a to the b times a to the c, that would give you a to the b plus c. Now, if you don't yet have these two rules memorized, you should definitely try to do that as quickly as possible, because there's no way to do your best on the SAT without knowing these two rules really well. The one we're going to use on this problem is the top rule, because we have a fraction with exponents in the numerator and denominator, and we have the same base. In this situation, we have x's in the numerator and denominator. So just like the top rule in yellow here, that means we should subtract the exponents, even if there is an exponent within an exponent, which is super strange. But it'll look a little something like x to the a squared minus b squared, and that's equal to x to the 16th. Now if the bases are the same and the expressions are equal to one another, then that means that the exponents are also equal to one another. So we can go ahead and say that the a squared minus b squared equals 16. Now when you have an expression like this purple one, that's two perfect squares with a minus sign in between. Well, a minus sign means something's a difference, and perfect squares can be called squares, so it's literally a difference of squares. And we have to know that an expression like that purple one, a squared minus b squared, is equal to the square root of each piece with a plus and minus, and it looks like this: a plus b times a minus b. Now that was equal to 16, so right now we have a plus b times a minus b equals 16. Coincidentally, the question told us that a plus b equals 2, so let's fill that in. And having a 2 right there will give us 2 times a minus b equals 16. A nice easy next step that we can do that'll take us to our answer is divide both sides by 2, and you get the 2's canceling on the left hand side, and a minus b equals 16 divided by 2, which is 8. So the answer for number 7 is A. Just a little bit of extra practice on differences of squares if you need it. Let's say that we had 25z squared minus 100w squared. It's a difference of squares because there's a minus sign in between. That's the difference. And both of these are perfect squares. So we take the square root of each piece with a plus and a minus, and it looks kind of like this. 5z plus 10w, 5z minus 10w. What if we had 49x to the fourth minus 36y to the sixth? It's again a difference of squares because we've got two perfect squares and a minus sign in between. So squares and a difference. And it factors to the square root of each piece with a plus and minus. 7x squared plus 6y cubed, 7x squared minus 6y cubed. That's definitely a big concept on the SAT, something you want to practice if you need extra help on. Question 8 is giving us a nice complicated looking word problem, but the most important thing that I think I'm seeing in the description here is the idea that the measure of the exterior angle is greater than 50. The measure of the exterior angle is A. So A has to be greater than 50. And we can do this question from the perspective of the approach that we call plugging in parameters. That means that if A is greater than 50, we should be able to plug in 50 as the limit and numbers that are greater than 50 to find out what the trend is when you do that. So we're going to plug in A equals 50, A equals 60, and A equals 90. Now why such random numbers? The 50 we kind of had to plug in because that's right where the wall is. Now A can never be equal to 50, but plugging in 50 will tell us that critical number that's going to be passed right at that moment. But we picked 60 for the second number and 90 for the third number because they're both divisible for the 360. 360 is divisible by 60 and 90. Let's go ahead and try that. For the 90, we have NA equals 360 and A is 90, so that would give us n times 90 equals 360. We can divide both sides by 90 and we'll get n equals 4. Now let's try it for A equals 60. Once again, n times A equals 360. A equals 60, so we plug that in, and then we divide both sides by 60 and we get n equals 6. Now we can do it by the 50, a little tougher here because it's not divisible in a nice way, but we can still do it quite easily. N times A equals 360 again, plug in A equals 50, and then divide both sides by 50, and we'll get n equals 360 divided by 50. Simplify by dividing both sides by 10, and we'll have 36 over 5. Turning that into a mixed number, 36 over 5 is the same as 7 and 1/5. So by plugging in parameters here, we've shown that when A is greater than 50, we start at a number of sides that's equal to 7 and 1/5. You can't really have 7 and 1/5 sides, but we know that it's a number greater than 7. And what happens as you keep plugging in numbers that we're allowed to plug in? Because A is greater than 50, so we're going in the greater direction. What happens to n? It gets smaller and smaller and smaller. So n is some number that starts at 7 and 1/5 and goes smaller and smaller and smaller. So what's the greatest integer value you can have? Because a number of sides can't be a decimal. Can't have a decimal number of sides. So what's the greatest integer we can have if we start at 7 and 1/5 and go in the downward direction? The biggest number we can have is the number 7. We can maybe demonstrate that on a number line. Here we have 7 and 1/5. Here we have 6, and here we have 4. And our true answer said that we were going to start at 7 and 1/5 and go in the smaller direction. So the next integer we would hit as we go to the left is actually 7. And then after 7, we'd have 6 and 5 and 4 and 3. So in this solution, if we're looking at only the integers that could be in the solution, that's the number 7, 6, 5, 4, 3, and so on, going in that direction, right? So what's the greatest number we can have there? The number 7, which is why the answer for 8 was C. Question number 9 looks like a question with a lot going on, but if you take it step by step, it's not so bad. First, we're hearing about a line that has a slope of 2, and it contains the point 1, 8. Chances are we're going to have to find the equation of that line, and the way you think about this is if you're being given a slope and a y-intercept, then you use the slope-intercept formula of a line, which is y equals mx plus b. If you're given a point and a slope, then you can use the point-slope formula of a line, which is y minus y1 equals m times x minus x1. So here we have a point and a slope, so let's go ahead and use that formula. And so if we plug in our point, the x will go in the x1 spot, the y will go in the y1 spot, and the slope will go in the m spot. And putting all that in there, we have y minus 8 equals 2 times x minus 1. Let's go ahead and simplify a little bit. We can distribute the 2, and that'll give us 2x minus 2. Now we can add 8 to both sides, and that'll give us y on the left and 2x plus 6 on the right. So we now know that the equation of the first line we were given is y equals 2x plus 6. Now for the second line, the one that goes through the points 1, 2 and 2, 1, we're given a point and a slope. We have the slope because if I'm giving you 2 points, I'm giving you the slope. And we definitely have a point because we actually have 2 points, so we have more than what we need in that sense. So let's take the slope formula first, and to be extra careful, we can label the points x1, y1, x2, y2, and so filling those into the slope formula, we'll have 1 minus 2 over 2 minus 1. Subtracting that out, we'll get negative 1 over positive 1. And that's just equal to negative 1. Now once again, all we need is the slope and a single point, so let's just pick either one of the points. We'll pick 1, 2, and we'll plug again into the point slope formula. So what we have right now has a slope of negative 1, and we're choosing to use the point 1, 2. So the x and the y of the point, the 1 and the 2, are going to go in the spots of x1 and y1, and the slope is going to go in the spot of m, negative 1 right there. If we fill in the formula around it, that gives us y minus 2 equals negative 1, x minus 1. Let's distribute the negative 1. That gives us negative 1x plus 1, because negative 1 times x is negative 1x, and negative 1 times negative 1 is plus 1. And now we can add 2 to both sides, and that'll give us y on the left and negative x plus 3 on the right. So the second line we were being given has an equation of y equals negative x plus 3. Now whenever you're being asked to find the intersection of two lines, it's always better to get the two equations in the y equals format and set those equal to one another whenever possible. You can't always do that, but if you can, I believe it's always the best method. Here, it's easy to get them both in the y equals format because they're already in the y equals format. We have y equals 2x plus 6 and y equals negative x plus 3. So the idea of finding the intersection is the idea of taking those two things and setting them equal to one another, because when lines intersect, their x and y values are equal at that moment. So we have 2x plus 3 equals negative x plus 3, and we can go ahead and take away 3 from both sides, and that'll give us 2x equals negative x, which is a little strange. Now we can add x to both sides, and we'll have x equaling 0. And to find out what y is when x is 0, we can just go ahead and plug in x equals 0 into either of the original equations. So right here, we'll have y equals negative 0 plus 3. So y equals 3. So we ended up with x equals 0, y equals 3. And the question said the intersection point is a comma b. So we got 0 comma 3. The question was calling those a comma b. So that's telling us that a is 0 and b is 3. And a plus b is going to be 0 plus 3, which is going to be b, 3. To answer question number 10, you'll need to know a little bit about parent functions and a little bit about function shifts. So let's talk first about parent functions. The parent function for choice A is y equals absolute value of x. And y equals absolute value of x is a V shape centered at the origin. It looks a little something like that. The parent function for choice B is y equals x squared, and y equals x squared is a parabola centered at the origin. It looks a little something like that. C has the same parent function as B, so just y equals x squared, which is another parabola at the origin, and the parent function for choice D is a cubic function, y equals x to the third. And a cubic function looks a little bit like a parabola on one side and a reverse parabola on the other. A little something like that. Now let's talk about function shifts. If I have a nice simple parabola, y equals x squared, just like the parent functions for choices B and C, then that's our parabola centered at the origin. And if we add something to the outside of that function, adding to the outside of a function is a vertical shift, and vertical shifts are normal. So the idea there is that if I add something to the outside, so y equals x squared plus 3, it would go up 3. Or if I take away something from the outside, y equals x squared minus 3, it will go down 3. So when you add to the outside, it's a vertical shift and it's normal. Positive is up and negative is down. Now if I take the same function, y equals x squared, and I add something to the inside, that's a horizontal shift. And horizontal shifts are backwards. So if I did y equals x minus 3 all squared, that's the format of a horizontal shift, but horizontal shifts are backwards. What I mean by that is, on the x-axis, the lateral axis that goes to the left and to the right, normally positive is to the right and negative is to the left. But if horizontal shifts are backwards, then minus 3, y equals x minus 3 all squared, means that we're actually going right 3. And if I had y equals x plus 3 all squared, once again it's a horizontal shift because it's on the inside, but horizontal shifts are backwards. Normally positive is to the right and negative is to the left. So x plus 3 all squared actually means we're going to the left by 3. So those rules are super important. They're definitely going to show up on an SAT, and so you definitely want to take some time to memorize them. Let's go ahead and apply those function shifts to these different choices. For answer choice A, we're taking away 2 on the outside of a function. On the outside is vertical, and it's normal, so positive is up and negative is down, so this is just going to go down 2. And the place that it'll go to is a y value of negative 2, because the origin was originally at 0, 0, and it went down 2. So right here, you have negative 2. For choice B, we're taking away on the outside. On the outside is a vertical shift, and it's normal, so negative is down. So we're going to take this blue parabola and move it down 2. And the vertex was at 0, 0, but it's been moved down 2. So now it's at 0, negative 2. Going to choice C, adding to the inside is a horizontal shift, and horizontal shifts are backwards. So x minus 2 all squared means that we're actually moving right 2, because normally positive is to the right, but this is backwards. So here, negative is to the right. So we're going to take that red parabola and we're going to move it to the right by 2, and it'll be right there. The vertex for that one is going to be positive 2, 0, but it's still at a height of 0. For choice D, adding to the outside is a vertical shift, and vertical shifts are normal, so negative is down. So we're going to take this function and we're just going to slide it down by something that looks like 2 spaces, but it really doesn't matter because the height of this function was going to go infinitely upward and infinitely downward anyway. So now let's talk a little bit about the question itself. The question said that y is going to be greater than or equal to negative 1. For inequalities, we always look to the line that could substitute for that inequality. So in other words, we look at y equals negative 1. And where would that line be? I'm just going to go ahead and draw that exact line on each of the 4 graphs. Y equals negative 1 is a horizontal line going through the y value of negative 1. So on answer choice A, it's around here. On answer choice B, it's around here. On answer choice C, it's around here. On answer choice D, it's around here. So for an inequality, you go to the line that relates to that inequality, but for greater than you shade above, and for less than you shade below. So we just drew in the lines y equals negative 1 on all 4 of these answer choices, but we're going to go ahead and shade above them because y is greater than or equal to negative 1. So the question says, for which of the following equations is y always greater than or equal to negative 1? Another way to say that is, for which of these situations is the curve always in the pink area? Notice that A, B, and D clearly have some portion of the graph that fell outside of the pink area, so the answer for this question is going to be C. Question 11 is a question on using the complex conjugate. Whenever you have a situation where you have 2 terms in the denominator, and out of those 2 terms, one of them is either an I or a radical, you're going to want to use this method. The conjugate is the same thing as the denominator with the opposite sign. And for any fellow nerds out there, the reason we use the complex conjugate is we're actually taking advantage of the idea of differences of squares. We don't really need to know that, but that's what's going on. So let's go ahead and just take the original expression. And what we mean by the complex conjugate is we take that 8 plus 2i and reverse the sign in the middle, and it becomes 8 minus 2i. So what we're going to do here is we're going to multiply by 8 minus 2i on the bottom and also on the top. So we're also kind of utilizing here properties of the number 1, because 8 minus 2i over 8 minus 2i, it's just the number 1. The number 1 is any fraction that has the same thing on the top and on the bottom. So when you multiply by the number 1, nothing really happens, but you can make things look really different when you do that. Let's go ahead and FOIL on the bottom. First times first is going to give us 64. Outer times outer is going to give us negative 16i. Inner times inner is going to give us positive 16i. And last times last is going to give us negative 4i squared. So far, that's what we have on the bottom. And let's go ahead and FOIL out the top now. First times first is 24. Outer times outer is negative 6i. Inner times inner is negative 40i. And last times last is positive 10i squared. Now let's combine like terms on the top and on the bottom. On the top we have negative 6i minus 40i comes out to negative 46i. And on the bottom, negative 16i plus 16i cancels out. So that totally disappears, leaving us with 64 minus 4i squared. Now another super important property to know of is that I squared is equal to negative 1. So on the top, that's going to give us 10 times negative 1, and that's going to become negative 10. And on the bottom, negative 4 times negative 1 is positive 4. So now we have some like terms on the top. 24 minus 10 is 14, minus 46i. And on the bottom, we have 64 plus 4, which is 68. Now another valuable property here is if you ever had anything in the format of a plus b over c, you should know that can be expanded out into a over c plus b over c. And that's exactly what we're going to do here. We're going to expand this into 14 over 68 minus 46i over 68. Now we can simplify the first term by dividing the top and the bottom by 2, and we'll get 7 over 34. And we can simplify the second term by dividing them both by 2, and we'll get 23i over 34. And so our answer is 7 over 34 minus 23i over 34, and that's equivalent to answer choice C. So in question 12, the really elaborate wording here is really just asking us to express the number of favorable reviews, which is f, in terms of the other variables. So basically the question is telling us, get f alone. So in the beginning of all of this, we can just simplify in any way we know how, and kind of see if that leads us somewhere valuable. So let's just go ahead and multiply both sides by n plus f. The reason why we're doing this is because it's going to cancel on the right-hand side. N plus f divided by n plus f cancels away. So we'll be distributing Rn plus Rf. On the right-hand side, we have f because the two pieces canceled away there. And the trick that's being used here is if you want to get a variable by itself, here we want to get f by itself, then one way to kind of think about doing that is getting everything that has an f on one side of the equation. So let's subtract Rf from both sides. When you do that, you get Rn equals f minus Rf. Having both of the f's on the same side, that allows us to factor out the f because there's a GCF here. Both of these green terms here have a factor of f, and if I divide them both by f, I get 1 minus r remaining. On the left-hand side, we still have Rn. That little factoring operation there allowed us to get f by itself because now we can divide both sides by 1 minus r. So on the right-hand side, we have f. On the left-hand side, we have Rn over 1 minus r, which matches answer choice B. Number 13 is asking us for the sum of all the values that satisfy this situation. Number 1, we should be noticing that there is a GCF, a greatest common factor. All three of these terms are all divisible by 2. If we do that, we'll get a simplified expression on the left, and we'll still get 0 on the right. So dividing everything by 2 on the left, we'll have m squared minus 8m plus 4. And like I said, dividing 0 by 2, you'll still have 0. Now what we have here is a quadratic, and the format of a quadratic is ax squared plus bx plus c. Now here they're m's, but it's the same difference. But because we have b and c coefficients, we'd normally be asking ourselves here, what two numbers add to negative 8 and multiply to 4? The problem is there's no two pair of integers that do that. So when you have a quadratic that doesn't factor, you have two options, completing the square and the quadratic formula. The quadratic formula is more familiar for most people, and the completing the square method is a little tougher to learn at first, but you definitely want to be an ace at the completing the square method. When you're sharp with it, it's going to get you out of jams really quickly and effortlessly. So for the completing the square method, you need that b coefficient, which is going to be negative 8. But first, you want to clear out your x's, or in this situation, your m's. In other words, we're going to take away 4 from both sides. That gives us m squared minus 8m equals negative 4. Now let's review the quick rules for the completing the square method. Like we said, the first step is to clear out your x's. So take away whatever is the c and put it on the opposite side of the equation. Then you want to get that b coefficient, which in our situation was negative 8. So you want to do b b over 2 and b over 2 squared. If b is negative 8, then b over 2 is negative 8 over 2, so negative 4, and b over 2 squared is negative 4 squared, which is 16. So b is negative 8, b over 2 is negative 4, and b over 2 squared is 16. Now for the completing the square method, you also want to know that b over 2 squared is what you add to both sides, and b over 2 is what it'll factor to after you do that. So the completing the square method tells us to add 16 to both sides. On the right hand side that gives us 12, and on the left hand side that gives us m squared minus 8m plus 16. So we could ask ourselves on the left what two numbers add to negative 8 and multiply to 16, but the completing the square method takes care of that for you. We already know this is going to factor to m minus 4, m minus 4. And the way you write it in the completing the square method is m minus 4 all squared. So m minus 4 all squared equals 12. Now this leaves us with something that has an exponent, and so to get rid of the squared, we can take the square root of both sides. Square root of m minus 4 squared is just m minus 4, and then we have radical 12 on the right, and so that's plus or minus root 12. Root 12 in radical form is the same as 2 root 3. So we'll say 2 root 3 on the right hand side, and still m minus 4 on the left hand side. Now if we add 4 to both sides, we'll have 4 plus or minus 2 root 3. So our two answers are 4 plus 2 root 3 and 4 minus 2 root 3. So the sum of our two answers are to add those two things. So we have 4 plus 2 root 3 and 4 minus 2 root 3. And what we're doing is adding those two. So what will happen here? 2 root 3 minus 2 root 3 totally cancels away, leaving us with 4 plus 4, which is 8. And the answer for number 13 is D. Question 14 is a question about a basic exponential equation. An exponential equation has the format of y equals a times b to the x. A is the starting amount, b is how it changes, and we're going to see that in a moment, and x is the number of times that change happens. So let's go ahead and see that in terms of this question. We have something that starts at 325 grams, and it decays at 13%. Now in terms of percentages, percents always start at 100%, and if we were to increase 13% from there, it would go to 113%, but if we were to decrease by 13%, it would go to 87%. Now in decimal form, the 87% would be 0.87, and the 113% would be 1.13. Here, we are decaying at 13%, so that's the 0.87, and so we're going to put 0.87 right here, and t is the number of years, the number of times that this is all going to happen. So the right answer to number 14 is going to be A, 325 times 0.87 to the t power. Now for number 15, the thing to notice is that some of the answers look like the results of division. When you divide, you end up with a remainder, and the remainder gets put as a fraction over the thing you're dividing by. So, if you haven't seen this yet, I definitely think you'll see a lot of it as you keep studying for the SAT, but choices C and D are kind of like hints that tell us that we might have to do division here. So this is the same as 5x minus 2 divided by x plus 3. And when you do synthetic division, which is the easier one, you want to divide by the root that goes along with this factor. So when we have something looking like x plus 3, that's the factored form. But the root that goes along with that is x equals negative 3. Just a quick word about that. For instance, if I had a question that said y equals x squared plus 7x plus 10, and the question said to find the x-intercepts, by the way, x-intercepts, roots, solutions, and zeros are pretty much all the same thing. So to find the x-intercept, the one-liner there is that y equals 0. So we'll take this and say y equals 0. You'll see why we're doing this little side example in a moment. But having it equal to 0 is our permission to factor. So this will factor to x plus 2 times x plus 5. Now we have the zero product rule that says that if these two things multiply out to 0, then we're allowed to set each one equal to 0. So we say x plus 2 equals 0, x plus 5 equals 0. And we can solve each of those. So take away 2 on the left, we have x equals negative 2. Take away 5 on the right, we have x equals negative 5. And so what are we saying here? We're saying that if we have a factor of x plus 2, it corresponds to a root of x equals negative 2. If we have a factor of x plus 5, it corresponds to a root of x equals negative 5. So for nice, simple questions, how do you get back and forth between factors and roots? By flipping the sign. Maybe if it's a little bit more of a complicated example, then we need to emphasize that you go back and forth between factors and roots by setting it equal to 0. Because x plus 2 equals 0 gave us negative 2. Or to go in the other direction, if I went ahead and just added 2 to both sides, that could be said as something that is setting one side equal to 0. So if x equals negative 2, the factor is x plus 2. Once again, at this level we call them factors, and at this level we call them roots, x-intercepts, zeros, or solutions. Now the reason we're getting into all that is that when you do synthetic division, the thing you're dividing by is not the factored form, not x plus 3, but the root that goes along with that, which would be x equals minus 3. So we're going to take x equals minus 3 and put it in the box. And then to divide, you take the coefficients of the thing that you're dividing. So the coefficients here are nice and easy. They're the numbers 5 and negative 2. So the next thing you do in synthetic division is you bring down the very first term. And the phrase you repeat to yourself when you do synthetic division is multiply, add, multiply, add. So if we had a bigger example with more than just 2 terms, we would be multiplying and adding as many times as the number of terms that we have. You'll definitely see more examples of that later, but for now, we're multiplying what we have right here by the thing in the box. So 5 times negative 3 is negative 15. Once again, the phrase is multiply, add, multiply, add. So we just multiplied, so now we have to add. We add straight down. Negative 2 minus 15 is negative 17. So we pretty much have our answer, but we need to understand what it is. When you do synthetic division, the number you get at the end is your remainder. The next number over is your constant. For instance, for a quadratic, the constant is the c. It's the number that doesn't have an x attached to it. And if we had more numbers, the next one would have been the x, and the next one would have been the x squared, and the next one would have been the x third, and so on. So when you have synthetic division, your answers are going in the order of the smallest number and the next smallest number, and then the x and the bigger x and the bigger x, and they kind of go in that general order. So we have a remainder of negative 17, and as I said a moment ago, the remainder in division gets put as a fraction over the thing that you're dividing by. And then we have the constant, which was 5, so 5 is a number with no x. And the answer is 5 minus 17 over x plus 3, which is choice D. Question 16 is really just a question about trying out different combinations of numbers. We know that there are going to be $250 bonuses and $750 bonuses. We need at least one of each, and the total is going to be $3,000. So that's a number of 250s and a number of 750s equals 3,000. So what if we had one 750? How many 250s would we need to satisfy that? So it's kind of just a nice algebra equation. 250x plus 750 equals 3,000. Taking away 750 from both sides, 250x equals 2,250. And then dividing that by 250, you get x equals 9. So we already have a possible answer, which is 9. There could be 9 $250 bonuses. But just to show all the possible answers, what if we had 2 of the 750s? And we combine that with x of the 250s, and we have another equation. So 250x plus 1,500 equals 3,000. Take away 1,500 from both sides. 250x equals 1,500. And 1,500 divided by 250 is 6. So in this situation, the number of $250 bonuses is 6. And last but not least, we could have 3 of the 750s. Add that with x of the $250 bonuses, and we have another equation. 250x plus 2,250 equals 3,000. Take away 2,250 from both sides, and we have 250x equals 750. Divide both sides by 250, and you get 3. So the possible number of $250 bonuses is either going to be 9, 6, or 3. We could have used any of those and it would have counted as the right answer. For number 17, most people who got question 17 wrong probably just didn't realize what a simple question it was. Let's just start by simplifying. Let's go ahead and distribute 2x into both of the terms next to it, 2x times 3x and 2x times 5. That's going to give us 6x squared plus 10x. Distribute the 3 into here and here. 3 times 3x is 9x and 3 times 5 is 15. Now we can combine our like terms and we'll get 6x squared plus 19x plus 15. The question says that equals ax squared plus bx plus c. Now the wording of this question says this equation is true for all values of x. So they mean that this situation has an answer of all real numbers. And all real numbers as your answer means that the two equations that are equal to one another are the same equation. It means that the a is actually 6, the b is actually 19, and the c is actually 15. So what's the value of b? 19, and that's our answer for number 17. Question 18 is a question about similar triangles. And how do we know these triangles are similar? Well, first of all, they share an angle right here. These are called vertical angles, and vertical angles are always equal. So right there we have one pair of congruent angles. Also, because the lines are parallel, we can get some congruent angles out of that. And the way to figure that out is when you have parallel lines, you want to look for C's and Z's. For instance, if I have parallel lines with a transversal in between, if I see a C shape like this, or a C shape like this, the inner angles of both of those C shapes have to add to 180. So angle 1 plus angle 2 equals 180, or angle 3 plus angle 4 equals 180. So out of the C's and Z's, if you see a C, you have two angles that are equal to 180 when you add them up. Now for the Z's, if I have two parallel lines in a transversal, and I have two angles in this formation, then the inner elbows of those, in this situation angle 1 and angle 2, are going to be congruent to one another. They're going to have equal angles. That also holds true if the Z is backwards. If the Z looks something like this, then the inner elbows of that are also congruent. So angle 3 and angle 4 in this situation are also equal. So just to recap, with parallel lines, if you see a C shape there, then the two inner angles are equal to 180, then the two inner angles add up to 180, and if you see a Z shape, then the two inner angles are equal to one another. So in our situation, if we see segment AD as a transversal, then we do have a Z shape. It's right here, and so from that, we know that this angle is equal to this angle. If we consider the backward Z shape, that would look something like this, and the inner angles of those are equal. So that's saying that this angle is equal to this angle. So now let's talk about the idea that we have similar triangles. Similar triangles have the same shape and different sizes. And because the three angles match up with each other for the two triangles, we know the shapes are the same. Obviously, one triangle is bigger than the other though. So we have two sides that are going from the black angle to the red angle. And in the top triangle, that's our x, our unknown, side CB. And in the bottom triangle, that's the 8, side BE. And then we can add in two more segments that are both going from the green angle to the red angle. So on the top triangle, that's our DB, it's 5. And on the bottom triangle, that's BA, 10. So we have x over 8 equals 5 over 10. So you won't have different colors to use when you do your own SAT, but we could have said we were going from the angles that have 1 mark to 2 marks to 3 marks and use that instead of colors. But whenever we have proportions, we cross multiply, so we can say 10 times x equals 5 times 8. 10x equals 5 times 8, which is 40, and x equals 40 divided by 10, which is 4. So we just found out that CB has a length of 4, and the question is asking us for CE. So be really careful. It would be very easy here to put in 4 as an answer after having done all the right work. But they weren't asking for CB, they were asking for CE. So that's 4 plus 8, and the answer to the question is 12. Question 19. In the xy plane above, O is the center of the circle. The measure of angle AOB is pi over a radians. What's the value of A? So the only information we have to go off here is the idea that point A has an x value of root 3 and a y value of 1. But that's actually a lot of information because we can draw a right triangle right here, and if the x value of A is root 3, that means that it went out sideways by root 3. And if the y value is 1, that means that it went up by 1. So we've got a right triangle with root 3 right here and 1 right here. So this is a very high-level concept. What we're being asked to do here is to identify that we have a right triangle with the elements of a 30, 60, 90 spread. Because in our formula sheet, we learned that for a 30, 60, 90 triangle, the side across from the 30 is x, the side across from the 90 is 2x, and the side across from the 60 is x root 3. So notice how we kind of have that. If x were 1, then 1 is x, and root 3 is 1 root 3. So it's lining up perfectly. That would mean that if x is 1, the hypotenuse is going to be 2 times x. So the hypotenuse would have had a length of 2, which we don't need here, but it's interesting. And with that lineup, that means that across from the x, the smallest angle, that's our 30. Across from the root 3, that's our medium angle, it's 60. And across from the 2, that's our large angle, that's our 90. So what we did here is we noticed that we had a right triangle with some of the elements of a 30, 60, 90, and from that we can get the angles. So angle AOB is this 30-degree angle here, and the question is asking for that in radians. Now the conversion between degrees and radians is that pi radians is the same as 180 degrees. So if we take that 30-degree angle that they're asking us about, we can use a conversion that says that pi radians is equal to 180 degrees. This is a unit conversion, chemistry style unit conversion. This thing that I'm circling in purple here, that's just the number 1, because if pi radians is 180 degrees, then pi radians over 180 degrees, or even 180 degrees over pi radians, is equal to the number 1, because a fraction with equal values in the numerator and denominator is equal to 1. So all we're doing here is multiplying by the number 1, but it allows the units to cancel. Degrees cancels with degrees, and we have 30 pi in the numerator and 180 in the denominator, but 30 divided by 180 would simplify to 1 over 6 if you divide them both by 30. So we have pi times 1 on the top and 6 on the bottom, and the unit is radians. So the question told us that the answer was pi over a radians, and we have pi over 6. So the value of a is 6. So question 20 is asking us about the different ways that two lines can interact. So we know these are lines because they both have x and y to the first power. And if you have two lines, there are 3 ways those two lines can interact. They can hit once, they can hit never if the lines are parallel, or they can hit always. If you went to graph one line and when you graph the second, you realize that they're actually the same line. So this is the idea of having one solution, 0 solutions, or infinite solutions. So in this problem, we're being told that the system has infinitely many solutions. So it's just like this example, they're actually the same line as each other. So if they're the same in every way, how do you get from 12 to 60? That's multiplying by 5. So if these are the same equations as one another, then that should hold true across the boards. To get from ax to 2x, we should also be multiplying by 5. So ax times 5 equals 2x. And same thing in the middle, by multiplied by 5 is 8y. So let's write that out. by times 5 equals 8y. Now in the top equation, we can divide both sides by x. 5a equals 2. In the bottom equation, we can divide both sides by y. 5b equals 8. Simplifying the top equation, we can divide it by 5. A equals 2 over 5. And the bottom equation, divide both sides by 5. B equals 8 over 5. So what's the value of a over b? A over b is the same as 2/5 divided by 8/5. Now when you divide fractions, we use the keep, change, flip method. You keep the numerator, you change it from division to multiplication, and you flip the denominator. So that'll be keeping the 2/5, turning this, changing it into multiplication, and flipping the 8/5, turning it into 5/8. So 5 on the top, 5 on the bottom cancels out. And now we have 2 divided by 8, which is the same as 1 over 4. And the answer to number 20 is 1/4. Thanks so much for listening to the answer explanations for College Board Test 2, Section 3. If you're interested in learning more about how Grateful can tutor you one-on-one, we tutor students anywhere in the world. Go ahead and reach out and let us know, and we'll be more than happy to help you out. Thanks so much, and have a wonderful day.